This next presentation is more about using Azure Application Lifecycle Management with AB Suite. It's not so much an AB Suite sort of presentation per se, but how to use the features that Microsoft Azure environment gives you when you're actually developing a AB Suite. So we're going to look at how it operates on a sort of day-to-day basis. How, as a actual developer, you would live with this. I'm going to assume that you've already installed actually DevOps or Azure DevOps, and you've configured your AB Suite actually development environment to run against it. There's some courses we can offer on how to do that. There's information on the Unisys support websites. So we're going to look at really, you've got it all working, you've got everything up and running. You're happily actually developing against AB Suite, and you're using Azure DevOps as a version control system. So what is it like on a day-to-day basis when you're using this thing? A couple of options I would personally recommend that you do when you enable all this is to work with Azure DevOps. There's an option in Azure to say every time you make a list of check-in, it must be associated with a work item. I would strongly recommend you turn that on, such that any change you make, for whatever reason, it has to be associated with a work item. That means that in 6 months' time, and when you think, well, who wrote that bit of code and why did they do it? It's there. If you just enable users just to check in work item or changes without a work item, you don't really know why they made the change. To me, the simple rule is no work item, no work. A developer must have a work item to work against. Also, enable the option to force developers, if you like, to key in a meaningful check-in. Now, unfortunately, meaningful, actually Azure DevOps says, okay, he's typed in a full stop, that's meaningful. You need to get your Azure developers to learn to put in some kind of really good comments as to why they're doing the check-in, what bug they fixed, or actually what they've done. During this presentation, I'm going to assume that you're using a variation of the Agile process. So there's a couple of terms that we need to understand and make sure that everyone is aware of. A sprint in an Agile environment is a time box period of work, if you like. It's normally less than a month. It can, in theory, be as long as you want, but typically it's less than a month, and often only about a week to 2 weeks. And the idea is at the end of each sprint, you have something which is working, and you could actually send it to your test teams as a working system. If there's something which takes more than your sprint period to actually develop, it still has to be in a state where you can release it, and even so that it compiles and releases. You may have to turn it off so your developers can't see it, or your end users can't see it, but it should, every time you reach the end of a sprint, you should have something that you can actually release to people to start actually testing. The backlog, if you like, is your to-do list. So any request which comes in, whether it's to develop a major new feature or fix a bug, goes into the actual backlog and is recorded in Azure DevOps as a work item. So any piece of work you do should be recorded in here. And the idea is that at the start of each sprint, or a few days before the start of each sprint, everybody decides what items we're going to take out of the backlog and what are we going to do within the sprint. Each item in the backlog has typically what's called story points. So it's not hours of effort, it's an arbitrary number as to how long it will take to implement this thing. And each actual developer has a field against them saying they can complete X story points per day. So using this, you can say, okay, we have features, and this particular feature is going to take 100 story points. So that's a big feature to fix. So that we can only do that one feature. We know we have a actually given number of story points in each sprint, so we can pick items out of the backlog until we know we've got enough work to do that. Everything in Azure DevOps is based on work items. Everything is tied back to a work item at some point. All changes, all requests for updates, anything to do with updates to your system should be logged and tracked using actually work items. The really neat feature of a work item is you can link them. So you can have a top level work item, which is maybe actually develop some major new feature for your system, and then break it down into a series of user stories and tasks. And then as you work on it, you may find that there is a bug associated with a particular item. And so you can link all these items together and see exactly the amount of work and effort that was done against that, what tasks you did to implement a feature, what bugs were found against it, anything else you find against it. So Agile supports a number of different types of work item, if you like, and these are all definable within the Azure DevOps environment. So when you create a new work item, it'll ask you, well, what type of work item is this? And again, it's configurable to some extent. Agile will give you like an initial sort of template, which is shown here, where you have epics and features and user stories. But if you want, you can create your own work items. You don't have to be restricted in terms of what Azure DevOps gives you out of the box. And I'll show you an example of that a little bit later on, where we've created a new type of work item specific for Agile Azure Business Suite systems. The big thing to bear in mind when you go down this route is you don't have to tie your development process to the way it says you have in Azure DevOps. If you want a slightly different variation of it, chances are you can change the DevOps processes to actually do that, and so you're not tied to the way that it says in the system. Each work item type goes through a series of stages. So by default, when it comes in, it'll be a new item, and then somebody can move it to an active item, and then resolved, also closed. And you can see here there's a wide variety of states that a work item goes through, and it has to go through the states in order. You can't just go from new to closed, for example. You have to say, well, you may be able to cancel it, but you can't just leap from one state to the next without going through the intermediary ones. And again, you can create your own work item states, if you like, or processes. So you may decide we need the triage state. So we're going to take a new bug, we're going to triage it and say, is it a really serious bug, or is it something really sort of trivial? We can leave to when we've got time within the backlog. So again, it's a way of you being able to configure the Agile or the Azure DevOps environment to match exactly the way that you work, rather than the way that Azure DevOps is saying this is the way that you should work. So we can actually extend it. You could create, if you want, say we will take the default Agile process, and we will create an AB Suite Agile process. And we can do this through Azure DevOps. It's fully supported. Go in there, take a sort of standard, one of their standards, and say, well, I like the Agile way of doing it, but I want some additional steps. I want some additional work items within this process to be able to go through and complete my normal Azure development process. So if we look at a standard work item, this is a new bug. So when someone says, okay, we found a new bug, they can go into Azure DevOps, and they can start to assign things. So they can give it as a general sort of title. They can even say who it's going to be assigned to. You can add your own user-defined tags to it. So this can be any text or word that you want, and you can have as many tags as actually you like here. And then you can search by tag. So you could search for all work items related to a particular feature, for example, or all work items which involve this particular method which had a bug in it. Steps on how to reproduce a problem. You know, whoever found this problem should enter steps in here to say, this is how I found the problem. This is invariably the biggest problem when you're trying to fix something, getting somebody to write down meaningful words in here so you understand how to recreate the problem. What software levels were you working? Which version of the system were you using when you found this bug? Well, the neat art is an actual discussion. So we can discuss about it. If I wanted to maybe ask Gary a question about, you know, how do I do this, I can actually discuss it with him in here, and we can actually record that discussion so that in 6 months' time, when we come back to look at this work item and say, well, why did you reach that conclusion? Why did you do that? Discussion about the thought process we went through to maybe fix a particular bug can be recorded here. And to me, that's one of the most powerful features is that in 6 months' time, I can go back and look, well, why did we reach this conclusion? What did we do? We can also record how much work we actually needed to fix the problem in real terms, so we can get more accurate estimates in terms of, well, this particular type of bug took us X hours to fix. And we can record the actual development history as to what's going on with it. And we can add links to it. So I can add, you know, a parent task, and I should add a parent task. I should say, well, this bug is related to this task or this epic or this feature that we're building. I can also create custom work items. So what I've done in this case here within Azure is say, okay, there's a new work item to define a new actual bundle within the system. We've decided we need some form of new user interface into the system, and it needs a particular subset of the iSpecs actually within there. So I can create a work item unique to creating user bundles, and I can add fields to this work item. So I can say, what is the actual generator name? What are we going to call this bundle, the thing which builds this bundle? Which iSpecs are we going to put into this bundle? So this is totally, and this is all stored in the SQL Active database and recorded in a normal way. So we've got a history now of everything we did to why did we decide to create this new actual generator, which iSpecs are in it, what its name is. So here's an example of a work item that is actually depleted. So we've got a whole set of how to reproduce the problem, what the original problem was. It was fixed in this build. If I was to click on this link, it would take me to the actual lines of code which were used, which I actually checked in to fix that problem. And I can see it's a parent task. And I can see any comments and history. So I can see I actually resolved it with this or change set, and this is the comment I entered when I fixed the problem. Hence the need to educate your users to put something meaningful in here, so you can say, well, that's what happened, and that's what they actually did when they actually changed it. You can also view the history of a work item. So when was it created, when was it approved, and when was it fixed? And it record all the actual discussions that we had about actually resolving that problem or any change in state. So it's at this point it would change from new to active, and then I changed it from active to resolved. And later I added a comment about it. So you've got a complete history of why you raised the bug, what discussions you had about fixing the bug, when the bug was fixed, and what lines of code that actually were used to fix the bug. Something else I would urge you to do is configure DevOps to send emails to people. Actually, Russell showed this a bit on his demo on Monday. But there's a whole sequence of actions and actually decision points that you can configure to say, when this happens, send an email either to a certain individual or to a group. So when a new work item is allocated, when it changes state, when a build is completed, or if it fails, you can also opt to actually follow a work item. So even if I'm not actually maybe involved in a particular bug fix or whatever, but I need to know that I can't do my work until this bug has been fixed, I could opt to follow that work item. And I will be notified by email when its state changes. So maybe when its state is changed to actually resolved, I can look at and say, okay, that bug's now been fixed. I can start to do my own work. Or if you're mentioned in a discussion, in the discussion for things, you can put at and then someone's name, and it will actually generate this email. So certainly in the current climate, where chances are your actual development team may not all be in the same physical location and may all be working from home, for example, then the ability to have emails sent to them when they're allocated some work or there's something they need to do is a very powerful feature. The thing I would recommend is you set up whatever email client you're using to create an extra folder and apply a rule. So when these come in, you can see them quite easily. I used this in practice on a project I worked on a couple of years ago, and it worked really, really well. The fact that I didn't, the manager or the project manager wasn't constantly going around the group saying, can you look at this bug, please, Nigel? I actually knew that there was a new piece of work to do because it just popped into my email box. So you'll get emails actually generated looking to this is a build succeeded message. So it's telling you what the fact the build worked. It's actually saying there's actually still a new task outstanding actually associated with this build that hasn't been worked on yet, and all the code commits that were done before this build actually started. So it's a good way of the project manager for tracking how they're getting on with resolving the various issues or bugs and new features that are needed to be fixed. Okay, now Andy mentioned this on Monday that you can version pretty much anything within the AB Suite actual repository when you're working on things. And so when you start to work on it, it will actually check that item out of Azure so that only that actual developer can work on it. The thing you need to be a little bit careful of is the way that AB Suite works out how much to check out. In this diagram, everything in green has its own version file and hence is a separately versioned item, and that's the item which will be checked out if someone decides to make some sort of changes to it. The items in blue don't have a version file, and the rule is AB Suite will work up the ownership chain until it hits something which has got a version file. So for example, in this case, if I as a Ash developer wanted to do some work on this description attribute, it hasn't got a version file, neither has a product, so it will check out the segment. And if you check out the segment, that means that a lot of other developers probably can't do anything else either. So you do need to be careful at looking at making sure that the items are versioned correctly. So to that end, we would recommend that when you're creating something new, always use the menu structure to add, and then select the Add New Item menu option, and a little dialog box will appear, and you can add in a new iSpec report or actually whatever you're working on. That will ensure that the version file is set correctly. If you don't do that, there's a risk you'll create something without a version file, and then you risk checking out more than you intended when you come to work on the system. If you do create new iSpecs, check them in almost actually immediately. So basically say, create new iSpec, get it checked in. That means that other developers who are also working on the system would also maybe add new iSpecs. If you don't, there's a risk that they will get stuck because you've checked out the segment level and no one else can actually do anything. The other recommendation, again, from personal experience, is if you're doing a branching, if you're branching something, make sure nothing is checked out. If you're branching with things checked out, you're effectively branching something on a moving to target. It's very simple. Just say, okay, we're going to branch the system this afternoon. Check in whatever you can and get it to a point where it's safe, and then actually perform the branch. And the way Azure DevOps works, it uses something called actually pipelines to control the process. And within a pipeline, there is a actual logical architecture of what's going on. So on the right, we have a whole bunch of actual logical servers. They don't have to be physical servers. In many cases, you could put the whole lot onto one server if you want. But typically, you'll have your Azure developers with their own Azure development environments on their local machines. You'll have an Azure DevOps server somewhere. You'll have a build server, the thing which actually builds your AB Suite system, and that could be on the same server or it could be on a different one. You have a release builder. Again, that could be the same as the build server, which could be the same as the Azure DevOps server, or it could be a different one. So there's a whole, you need to understand and decide what your environment is going to be right up front before you start actually doing any of this sort of, seriously. So there are two different types of pipelines. There's a build and a release process. They are somewhat overlapping. In theory, you can use your build pipeline to build and perform the release, but the ideal way is to have a build process or build pipeline which builds your system and only builds it, and a release pipeline which actually releases it and only actually releases it. So as it says here, the build recompiles it and maybe creates all the artifacts you want to do. It'll build your AB Suite system. If you've got a bunch of custom clients, you could rebuild those as well as part of that process, but it doesn't actually release it. It's compiled it all up and it's good to go, but it hasn't done the physical actual release. And then the release pipeline takes whatever artifacts you've built within the build process and then you copies them to the appropriate location. So they're two distinct separate processes, and the way you control how one is triggered after the other, there's a huge variety of choices. On Monday, actually Russell showed you a demo when he sort of checked something in and instantly started a build. So that's one way of doing it. Normal, continuous integration. Every check-in triggers a build. You need to be, if you've got a very big system, that may be something you need to possibly not do because it takes time to do. Also, if you're using the TFS DevOps environments to share code, so if maybe actually Gary and I are working on a new feature together, and he needs a new version of whatever method I'm working on, I can check that method in. Gary can do a get latest to get hold of that code. At that point, we possibly don't want to trigger a check-in, but it's entirely up to you. If you want to force a build every time we do a check-in to make sure it still compiles, that's fine. The other variation on that is a actually gated check-in, which basically says you must have built it locally before you actually check it in. So the Azure developer must have built the system locally on his machine before it can be actually checked in. You can also actually schedule a build to run at various times. So what I've done in this example is say it's 3 a.m. every morning, Monday to Friday, we're going to trigger a build. So every day when the developers come in or the testers come in, maybe there should be a new system for them to test. So you can trigger this at any time you like, and it says here it will only do the build if there's something worthwhile doing. If nothing's changed on that day or nobody's checked anything in, then there's no point doing actually a build. Similarly with Azure Release Azure Pipeline, you can configure it to release it continuously. Every time there's a build, do a release. Or again, at certain times, the same way as you can do a build. Maybe at 5 a.m. every morning, we're going to actually trigger a release. And the release pipeline can deploy to more than one server, or deploy to more than one thing, if you like. So we could actually deploy all the core Agile, the Business Suite applications to one server, and deploy all the custom client software onto another server. And that can all be controlled and configured through the release pipeline. We can also set it up to so there has to be an approval for a release. Maybe in your environment, maybe the project manager or the team manager has to approve a release or a particular process before it happens. And that's also possible to do within Azure DevOps. And whoever is actually nominated as the approver will get an email saying, is it okay to perform the Azure release at this point? Now, actually Gary mentioned this, the automated test tool. It's built into Agile Business Suite, so if you're using Agile Business Suite now, you've already got it. It creates a standard .NET test application. So if you're used to C# and writing test clients or whatever, it looks exactly the same as the code that's for C#. ATT basically generates all the code actually for you. So it's a good way of automating your testing. So maybe every time you do a release, you run a bunch of very simple automated tests to make sure you haven't really actually broken anything and everything is still working. The way it works is someone has to record a script saying this is what should happen. And there's an option in all the Unisys actually generated clients, like the VB Forms client and all the others, to enable creating an ATT test. Alternatively, if you've written your own clients within a component enabler, there are a couple of new or extra methods to say turn on the capture process, turn on creating an ATT script. A few testing guidelines. Remember that every test that you run will open a new connection with your AB Suite system. When you create the test, it will be called something probably not very useful, like test method 1 or test method 2 or test method 3 or something. The convention we use on a project is that the test always starts should. This is what the test should do. It should return the other customer name. It should increment the account number. You need to make tests run actually quickly. They should run within a couple of seconds. You don't really want to be starting some mega report as part of an ATT tests. And they need to be repeatable. If you have a test which says add £10 to the account balance, and it was £100, it should now be £110. That test will work the first time, but not the second time, because your database has now been updated to say the account balance is now £110. And there's a couple of ways you can get around this. There's a test initialize and test cleanup method within the ATT test. So you could put code in there to maybe restore some data. Or the technique we've used in the past is put something else into the release pipeline and copy the test version of the database back. So when you start the test, or when you perform a release, the first thing it does is to copy some test database back so it's in a known state. You also need to be careful to make sure you don't rely on some external system. If your test code is invoking something like an external web service, that external web service may not be there. So you need to think about making sure the test will work in all cases and not relying on some external system to be there. If it has to work that way, write what they call a bit of actually mocking code to mock what that external system should do and what response you're expecting back. When you run a test, you will get an XML file come out. Again, Russell showed this on his demo on Monday. So it will show you for every field on the screen what the field, so we have here a field called form name, and the test is that the value should equal STU. So it's saying here, this is what we tested, we were expecting this, and this is the actual value we got back. So that all passed. And the outcome of this particular test was the whole thing passed. So you can run this directly from Visual Studio. You can go into Visual Studio, right-click, run my tests. So if the developer has reached a point where they think, yep, that should all work, run the test and see what happens. You can also start to look at like a test-driven actual development, which is a different sort of paradigm where it takes a bit of getting used to in that you write the test first, and then you write the code. So the idea is you define an iSpec, create some tests, and then run it, and they'll fail. They'll almost certainly fail. And then the actual developer writes the code to pass the tests. The idea being is you only write the code to pass the tests. You don't write anything else. It's a different way of actual development. I have used it. I found it quite, it's quite a mind shift to go down this approach. But if it's something that your team is keen to move towards, it's certainly possible to do. Okay, so let's put all that lot here together and see what happens if we do this. This is a manual queued build. So I've decided to do a build, and we're going to start a new build of my system. So we will queue a build, and it's showing it's a manual build for me, and it's now found an agent on the build server, and it's going to do the build for me. So this is only a one iSpec system, so it doesn't take very long to do. So it's doing the build of the process, and it's compiling up any other little bits and pieces that it needs. What it's not doing is the actual release. At this point, we know the thing's built. So if configured, we would get an email. And what I've told you to do is, when the build completes, send an email to somebody and say, is it okay to do an actual release of this? So it needs the approval to actually start the build, if you like, or the creation of the actual system. So if I approve this actual release, it's now starting to do the actual creation of my system. So it's going to stop the old version. It's going to create the new version, and then it's going to deploy the new version of the system onto the appropriate server. So this is totally automatic. From 6.1 onwards, there's a lot of steps can now be configured through PowerShell to do all of this. So all this is actually being automated. So it's finished doing the actual deploy, and now it's going to run some tests, a few simple little tests, to just sort of shakedown tests to make sure that everything's still working and we haven't actually broken anything. So it's finished the test and it's not good. We have actually broken something. So we can get the results published back into the test plans so we can see what happened. So we have a full history now of all the tests we did and what happened. I can go in and look at this completed item and it failed pretty badly. Nothing worked. So we need to go and see what happened with that. So we'll look at the test results. It should return 3 students, and it didn't. It failed. It failed badly. So we need to look at what happened. So we can go in and say, let's go and look at the attachment. So this is the thing that ATT built. It's now in Azure DevOps. So we can see that, okay, the transaction failed, the student, it didn't find it. So we'll go back in and we'll create a bug from it. And it will put in the steps we need to actually reproduce that. So then I can assign that to someone to say, look, you know, we still haven't fixed this problem. You need to go and have another look at it. You could also make it a slightly more actually complex build. These little sort of person symbols here, if they have a sort of tick against it, it means it needs some kind of manual step or intervention to say, yes, you can go ahead and actually do it. So the example I've just shown did these first two steps. It built it and it ran some sort of tests. What I could then say is, okay, if all the tests pass, automatically go away and create a unit test system on some other server, actually deploy it again, clone it and call it a different system and put it onto our unit test server. But don't create the performance test. The little tick means that someone's got to authorize that. Start the process, but send someone an email saying you need to authorize this process. And then when they authorize it, it will create the Azure performance test system for you. A couple of other features which I suggest you use. Again, this is based on personal experience from working on a fairly major project for a number of years. Create a wiki, like a Wikipedia. Store useful stuff in your wiki about how to do things. How to set up ATT so you can actually record a sort of script. How to invoke a particular external method to get an answer back. What external methods are there available? Put it all into your little, and it's all there within Azure DevOps. You can also create hooks into other things. Trello is like a board with like these little yellow marker stickers that you can put on a board and say, I need to do this, or this is the current state that we're doing things. It's got hooks into Trello. It's got hooks into Jenkins, and there's a huge number of these external services that Azure DevOps has a hook into. So you're not even restricted at times to doing everything through Azure. Jenkins does many things similar to the way that Azure does it. So maybe you want to hook into that actually as well. So Azure DevOps is much, much more than just a version control system. You know, if you're using it to just manage source control, you're only scratching the surface of actually what it can do. There's no one-size-fits-all your solution. The answer to how to use Azure DevOps is whatever works best for you. You know, tailor it, configure it, make it work the way you want it to work, and let it. And then it's very, very good at managing and controlling the overall processes. It's extensible. There is a huge marketplace actually available. If you go to this website, marketplace, visualstudio.com/Azure DevOps, there's a vast number of add-ins that people have actually written to extend the basic environment. Some of which are free, some of which you have to pay for, some of which you can get on a free sort of trial. But things like being able to export everything into Excel, export all your details into Excel. On one of the slides I showed earlier, there was like actually a graph showing the actual relationship between tasks. That was done by using one of these add-ins. There's a massive number of add-ins you can add in to make the system work the way you want. So I would urge you to look at Azure DevOps, use it to its full Azure capabilities in terms of not only version control, but also managing your Azure development processes and also the build and actual release the processes. Okay, thank you very much. Thank you for your time.
Hi, Joe. I think there are several questions. Some of them responded by Andy, some still open, right?
There's the first question that came in is one that we've deferred to you, Nigel. There was a question about what artifacts do you mean in the context of AB Suite, or what AB Suite artifacts were you referring to?
One is the actual system itself, if you like. So in my case, I've got a simple AB Suite system called actually SchoolSys. But the other artifacts may be your clients, or anything else you build, or for example, if your AB Suite, your solution is much part of a much bigger solution, and you've got straight C# elements within that project, they are other artifacts. It's virtually anything else. It's your AB Suite system and anything else which goes around it, really. Any artifacts, any batch files, any scripts, any PowerShell elements, anything that's associated with the AB Suite system.
Thank you. I think we answered most of the other questions. There was a final question came in about SonarQube available for LDL+. I'm afraid I have no idea what SonarQube is, but
I need it from memory. SonarQube is something which checks that your code meets certain coding sort of standards. But I would have to check. I would have to check.
That will work.
Yeah. I think we did look
again, if it's a requirement, or you believe it's a requirement, I mean, that's something to raise as an NFS.
Absolutely, yeah.
I mean, through DevOps or through Azure, we can include or require code reviews to take place as part of the code progression process. But at this point in time, no, I don't think we have any kind of automated code quality checking tool. So again, as Gary says, you know, place an NFS, raise an NFS, and get the requirement on the books, and then product management and engineering can go away and take a look at that.
And I would say, I mean, it is a request, that sort of code quality review type process, whether you use SonarQube or something else, that sort of idea has come up by a number of other clients. And one of the challenges we've always said back to them is, what would you consider as good quality code? And part of the problem there is what's good for one client is not necessarily good for another. So, you know, if you are going to raise an NFS, or even if you just want to put in some ideas, put down what you consider and why you consider particular code constructs as good or bad, and in what context. And maybe between that sort of list, that's something we can both get engineering to think about, and maybe we can look at alternatives in the short term as well. And I think there was another question there as well. I think you answered it already, Andy, but somebody asked about, is ATT, can it be used for testing batch? And the answer is no, it can't be used for testing batch. But one of the challenges with testing batch is, how would you consider, or what would you consider the way to test batch? Is it, you know, would you look at testing some output files, or would you want to be comparing the database? You know, what would it be that you would consider as a valid way of confirming a batch process has given the same result? I mean, ATT works on the premise of, you know, the field was originally XYZ. Is it still XYZ? Yes, then that passed. That's relatively easy. But how would you do, or what would you consider to be the appropriate thing that you'd want to be able to do for a report? And again, I think that's something that we would get different people's views on. But, you know, let us know those views, because from that we can start looking, is there opportunities to build something that will achieve that for you?
Okay, question just came in for you, Nigel.
Do they have stats on bugs? Yes. There's all sorts of tracking you can do, and posting of figures, so you can track the bug rate. You can track how long it takes out on average for bugs to fix. And I probably need to do a little bit more checking before I answer you. I need to give you some full examples, but yes, it does have stats actually on bugs. We use Jira for tracking and changes. Would you need both? I can't answer that immediately. We would have to do a bit of research for you.
I mean, what I was saying that Matt, is that it's a standard product. We use Azure. Maybe we're not the right people to be asking if Azure has those features or how it interacts with Jira. Maybe use your Microsoft contacts to give you some of those answers.
As Nigel says, there's a whole bunch of plugins and third-party add-ins. I would be amazed if there wasn't something that would allow you to either replace what you're doing today in Jira with something in Azure DevOps, or allow Azure DevOps to hook into Jira in some way. Don't know the answer definitely, but as I say, based on the fact that it's we're only leveraging the actual standard Microsoft product, I would be amazed that there isn't already something that will already answer that particular question.
I'd agree. I think there's almost certainly something out there, either in the standard product or one of these add-ons.
Okay, so looks as though the questions may have dried up. I think we're probably done.
Okay.
The questions on the Q&A panel as well, you may have just confirming. Okay.
We just picked out the ones that were unanswered or needed a bit of clarification. So I'm happy that we've answered all the ones that came in.
Sure. Good. Thank you.
All right. So before we close, one last thing. We are interested in your experience during this AB Suite user conference. Therefore, I will send out a event feedback form asking for your opinion and your view. So looking forward to your responses. Anything else from you guys? Andy, Gary, Nigel, Tanga, you want to say?
No, I mean, nothing for me. I think, that a lot of questions have been asked, and hopefully we've answered them all. But as and when, if people have any further questions, then feel free to reach out to us. I guess the only other thing, Carol, would be a time frame for making the presentations and the recordings available.
I think we should be able to do it by next week, during the next week.
Well, maybe you send out that information with the questionnaire or with the feedback survey.
Yes, I can do that, I think.
Okay.
All right.
Anything else from me?
So nothing from myself other than to really thank everybody for attending and participating. I mean, the fact that we've had so many questions come in as well is suggests that people have got hopefully got something out of this last few days. It's appreciated.
Thanks everyone for actually listening in and attending.
Indeed.
I would say it's been a fantastic 3-day sessions. I mean, though the physical, face-to-face meeting did not happen, I think we still made this a great success through this virtual meeting. Thank you all for the wonderful effort, and thank you all so much for those wonderful questions and great participation. Thank you so much.
All right. Thanks everyone for joining.
Thank you. Bye-bye.
We are closing the event now. Goodbye.
Thank you. Bye-bye.